Bismillahirrahmanirrahim. For today, we are going to speak about finding the area included between two functions, or area under a curve, or area between two curves. Starting with this, first of all, we say that if we have two functions, f and g, and these are continuous on an open interval, a to b. If the function f of x is greater than the function g of x for all x in the interval a and b, then the area of the region enclosed between these two curves, or just bounded by f of x up, g of x down, on the left by the line x equal to a, by the right x equal to b, will be given by the formula a equal to, see, I have two functions, up f of x, we have down another function g of x, and these are continuous over the interval a to b. Then the area of this region bounded by the function f of x from the above and down from the, or by g of x from left by the line x equal to a, this one, and from the right by the line x equal to b, is given by the integration a equal to this definite integral from a to b of the difference of the upper function minus the lower function dx. This is the formula for the area of the region enclosed between two curves and two lines a and b, given by the integration or definite integral from a to b of the upper function minus the lower function. We can think about this one like that. We have rectangle. For the rectangle, we have the height will be given by f of x minus g of x, because this down is g of x. The height of the rectangle is the upper function minus the lower function. This is the height, and the width is the difference between a and b. We can just think about it in this way. So the area is the integration. Since we have continuous, we can make many rectangles like that, and then we add all of them. But since these are continuous, we are using integration. So the area is equal to the integration of the upper function minus the lower function with the limits a and b. Let's apply this one for some examples. Example number 1. Find statement, sketch the region enclosed by the curves. And find the area. Example number 1. With that, we are given y equal to x squared, and another function y equals square root of x, and x equal to 1 over 4, and x equal to 1. First of all, let's sketch the region first. Just to know that without that we have only one area or two areas in this one. Because in some cases we will have more than one region enclosed between the curves. Now, to graph the first function, y equal to x squared. We know this is parabola. And if you don't know how to graph this function, we can use floating points technique. I have x and I have y. We can use different values for x, and then we find y. For x, we can choose any value. For example, I will choose -2, -1, 0, 1, and 2. Since I have x squared, choose negative and positive numbers or values. Now, if x equal to -2, y equal to x to the power 2, just square it. You will have y equal to 4. If x equal to 1 or -1, -1 to the power 2 is equal to 1. If x equal to 0, y equal to 0. We are using this equation. Y equal x to the power 4. I'm sorry, x to the power 2. If x equal to 1 to the power 2 is 1, and if it is 2 to the power 2 is equal to 4. So we have 5 points. We can graph the function. First point, okay, -2 and 4. This is 1, 2, 3, and 4. So this is the first one, -2 and 4. Second one is -1 and 1. Is this one. Third point is 0 and 0. I have 1 and I have 2, 1 and 1, 2 and 4. If you connect between these, you will have something like u. This is a parabola. This is the graph of y equal to x squared. This parabola open upward. So we sketch the first function. Second one, y equal to square root of x. Again, but this time I have square root of x, so x must be a positive number. And since we have square root, we can choose 1, 4, 9. Just that will give me integer numbers. If x equal to 1, square root of 1 is equal to 1. If x equal to 4, y will be 2. If it is 9, I will have 3. If it is 16, I will have 4. So it is 1 and 1. At this point there. 2 and 4. Sorry, 4 and 2. This will be 3 and 4. 4 and will be 2 somewhere there. Or it is this one. It is accurate. And 9 will give me with the 3. I will have something like this. This is the function y equal to square root of x. More accurate. To be something just approximately like this. What I have here, it is not that much accurate, but this will be the sketch of the two functions, y equal to x squared and y equal to square root of x. Also, I have the two lines, x equal to 1/4 and x equal to 1. 1/4, okay, this is x equal to 1, it is this one. And 1/4 will be this one. I'm going to enlarge this area. So we need to find the area of this region. Between 1/4 and 1 and the upper function is y equals square root of x. Lower function is this one, y equal to x squared. So the area in this case equal to limit 1 over 4 up to 1. Left limit for x is 1 over 4 and right limit is equal to 1. Just to make it clear, this is the graph. I'm just enlarging the same thing here. This is 1 and this is 1 over 4. And we are looking for this area. This is y equal to square root of x, and down is y equal to x squared. So the area is the upper function minus the lower function. The upper function is square root of x, lower function is x squared dx. So the area equal to the integration 1 over 4 to 1 of the square root of x minus x squared, upper function minus the lower function, which is equal to, now integrate, or just write it, x or square root of x is x to the power 1/2 minus x squared dx. Integrate, and for the integration, definite integral, we add 1 to the power and divide by the new power. So I'll have x to the power 1/2 plus 1 is 3 over 2. So divided by 3 over 2 minus x to the power 3 divided by 3 between 1 over 4 and 1. This can be written as 2 over 3 multiplied by x to the power 3 over 2 minus 1/3 x to the power 3 between 1 and 1, or 1 over 4 and 1. Now find the value. When x equal to 1, it is 2 over 3 to the power 1 minus 1 over 3 multiplied by 1. This is the value of the function at the upper limit, minus, now replace x by 1/4. It is 2 over 3, 1 over 4 to the power 3 over 2 minus 1 over 3 and 1 over 4 to the power 3. You can use the calculator for this one. 2 over 3 minus 1 over 3, the first bracket will give me 1 over 3, minus. Second bracket is 2 over 3 multiplied by 1 over 8. This is the square root of 1 over 4. All to the power 8 is, all to the power 3 is 1 over 8. Minus 1 over 3 multiplied by 1 over 64. So it is 1 over 3 minus 2 over 24 minus 1 over, this will be 128, 192. And this can be simplified to be common. The method is 192, it will be 64 there, minus, this will be multiplied by 7, or just use the calculator for this one. That will be 192 divided by 24. Yeah, just multiply by 8, that is 16 minus 1. 192, and this will be 17, will be 47. So it is 47 divided by 192. So the area of this region will be 47 over 192 squared unit. So the idea is just integrate or construct the definite integral. See which function is the upper one and which function is the lower one. Then it will be the upper function minus the lower function, and the limits of the integration will be the values of x. Let's take another one. Number 2. We need to find the region of the, or the area of the region enclosed by the curve y equal to x plus 2, y equal to 0, x equal to minus 3, and x equal to 3. First of all, let's graph the region first. The first function, y equal to x plus 2, it is a line. This is a line. For the line, it's enough to find 2 points. We can use the x-intercept and y-intercept. If x equal to 0, y will be 2. If y equal to 0, I will have minus 2. Using x-intercept and y-intercept. This is 1, 2, 1, 2, 1, 2, and minus 1, minus 2. It is 0 and 2, it is this point, and 0 and minus 2, which is this one. This is the graph or the sketch of y equal to x plus 2. Now the second function says that y equal to 0. Y equal to 0 means x-axis. This is the x-axis. This is y equal to 0, this one. And we have x equal to minus 3. Minus 3, we use this one. This is minus 3, and the line will be this one, vertical line, and x equal to 3. This is the 3, and we have vertical line. Now I need to find the region enclosed between these curves. And you can see the region is this one. It is this one, this part. I call it A1, and this one, this area. It is A2. Because I have intersecting point between the interval minus 3 and the 3. And that's why we need to sketch the region first, because I need to check whether that we have an intersecting point in between the upper limit and lower limit or not. If I have intersecting point, then I have 2 areas, A1 and A2, and the total area will be A1 plus A2. So the area of this region, area equal to A1 plus A2, which means I have 2 integrations. We have 2 integrations. For the first area, A1, which is this part, lower limit is minus 3. The left limit, or the left line, is minus 3. It's clear. The right limit, which is this vertex, it is this one. This point is minus 2. From the table we know it is minus 2 and 0. So this one is minus 2. The upper limit is minus 2. Now for the first area now. The upper function is this line, y equal to 0. Lower function is the red one, y equal to x plus 2. And as we said, the area equal to the upper function minus the lower function. Greater one minus the smaller one. The greater the upper function is 0. The lower function is x plus 2 dx. See? In the first area, the upper function is y equal to 0. The lower function is y equal to x plus 2. So it is the upper minus the lower, 0 minus x plus 2. Now for the second integration, the lower limit is minus 2. The upper limit is 3. Let's speak about now this integration, this area, from minus 2 to 3. The first one was from minus 3 to minus 2. The second one from minus 2 to 3. Now in the second area, the upper function is the red one, which is y equal to x plus 2. So this is equal to x plus 2 minus the lower function is 0. We have to be careful about the upper and the lower function for the restricted region. Now we can evaluate the integration. I can take, go 0 minus, I will take the minus outside of the integration minus 3 to minus 2 of x plus 2. Put the negative outside. Or I can say minus x minus 2 dx. Plus the integration from minus 2 to 3 of x plus 2 dx. Let's evaluate. First one is minus of 1/2 x squared plus 2x. Limits from minus 3 to minus 2. Plus second one, 1/2 x squared plus 2x from minus 2 to 3. Now the value of the first bracket, first integration is equal to, I have minus outside. Find the value at x equal to minus 2, it will be 1/2 minus 2 to power 2 plus 2 multiplied by minus 2. This is the value at the lower, or I'm sorry, at the upper limit minus. Lower limit is 1/2 multiplied by minus 3 to power 2 plus 2 times minus 3. This is the value of the first one only. Plus second one, I'll have 1/2 multiplied by 3 to power 2 plus 2 multiplied by 3 minus 1/2 minus 2 to power 2 plus 2 to multiplied by minus 2. And this is the value of the second one. Evaluate. You can use the calculator to find the direct answer for this one. It is minus, it will be 2 minus 4 minus 9 over 2 minus 6 plus 9 over 2 plus 6 minus, that will be 2 minus 4, which is equal to minus, that will be minus 2 plus 9 over 2 plus 6. This is the first bracket, plus 9 over 2 plus 6 plus 2. And that will be plus 2 minus 9 over 2 minus 6 and plus 9 over 2 plus 6 plus 2. This will cancel this one. This will cancel 6. The answer is 2 plus 2 is equal to 4. So the answer is equal to 4 squared unit. So the area of this region is equal to 4 squared units. So again, start over again. We need to sketch the graph just to know whether that we have intersecting point between the interval or not. If we have, then we must have two areas, A1 plus A2. The first area is integration from minus 3 to minus 2. This will be the limits of the upper function 0 minus x plus 2. The second one from minus 2 to 3, the upper function is x plus 2 minus the lower function, which is 0. So it is x plus 2 minus 0. Then integrate or evaluate the definite integral, find the values, and add them together to find the final answer, which is equal to 4 in our case. So the area of this region is equal to 4.